On Mind and Reality, thinking about induction so far, we've encountered two problems. One was Hempel's ravens, or Aisha's traffic lights, and the other was the problem involving Grue, sometimes called the new riddle of induction. Now, I looked at other courses introducing philosophy, and I found that most of those tend to focus on the new riddle Grue problem, but I don't think that's such a deep problem. Indeed, I think there's a fairly straightforward, not terribly controversial solution for it. So let me see whether I'm right. Let me introduce this straightforward, not terribly controversial solution and see if you find it convincing, or perhaps I'm missing something. Perfectly possible. I'm going to introduce this slowly, step by step, before reaching the conclusion that Grue is much less despicable than you might be tempted to believe. Start with the notion of a biased sample. So here I am, I want to find out whether people were willing to answer a survey. So I give them a survey. Would you be willing to answer my survey? And what I find is that 100% of those completing the survey said yes, they would be willing to answer my survey. So I conclude that everyone would answer the survey. Now, of course, I'm very unlikely to get 100% because people tend to answer these questions at random a lot of the time. So let's say it was 85 or something like that. Still, the sample that I've collected provides me with very little basis for the conclusion because it's clearly a biased sample. Now take a look at the contrast that we came across earlier between the bad argument, I've run numerous traffic lights without accident, therefore I can run these traffic lights without accident, and the better argument, I've never seen Aisha stop for a red light, therefore Aisha will not stop for this red light. Why is it that one of these is bad and the other is good? Well, I want to say that this one involves a certain kind of sampling bias. Here's the thing. When I run a traffic light and there's no accident, that's an observation which I'm very likely to report. But if I run a traffic light and there is an accident, well, I'm probably too injured or dead to report it. So, of course, my method of sampling is likely to involve only occasions where I run traffic lights without accidents. It's much less likely to include the opposite type of observation, which would refute the conclusion. Now, if we go over here, what's curious is we actually find very similar kind of bias. If Aisha does stop at a red light, I'm more likely to report that observation than when Aisha doesn't stop at a red light. Why is that? Well, when she doesn't stop at a red light, the risk of accident death is much greater than when she does stop. So it's more likely that I'm going to report a case where she does stop at a red light than where she doesn't. What's curious though is that that sampling bias doesn't actually count against this argument in the same way, because that sampling bias actually makes it harder, not easier, for me to establish the conclusion. So when you've got bias that works against your conclusion, it doesn't undermine the confidence that we should have in the argument necessarily. Whereas by contrast, when here we've got bias that actually ensures we're sampling in a way that makes it more likely that our samples will support the conclusion, we shouldn't be confident in that argument after all. So what I'm suggesting here is that there is a bias. You're more likely to report an observation like this than to report an observation involving an accident, because you'd be injured or dead in the case of an accident. And that bias makes it easier for your sampling process to support the conclusion, not harder, and therefore undermines the argument. Very simple idea, entirely uncontroversial, I take it. Here's a second thought. I made up a story just for you to illustrate this point. This is a story that I made up. So although most of my ideas are stolen from other philosophers, of course, this is really me. I'm quite happy about this story. It's called The Sad Happy Story of the Beloved Ruler. And here's the thing about the beloved ruler. Her subjects lived in the most utter abject misery, right? But they loved their ruler with an uncommon intensity. Being the object of her attention even for a moment makes the subjects blissfully happy, but only for as long as they have her attention. Right after her attention moves on, they return to a state of abject misery. So you can imagine what's coming. The beloved ruler reasons as follows. all the subjects that I, the beloved ruler, have observed are blissfully happy. Therefore, all the subjects are blissfully happy. What's wrong with this argument? What's wrong with this argument? Well, once again, we've got a kind of bias in our sample. But the bias now is a little different. It's that the process of observation is changing what I'm observing as the loved, beloved ruler. I'm changing what I'm observing by observing it. So of course, because I'm changing what I'm observing in a way that makes it more likely that I'll support the conclusion, I should no longer rely on this argument. Once again, I've got a kind of bias in the view. I think maybe you can see where this is going. Let's find out. You remember that Goodman's puzzle was the challenge, really the question, why is the left argument, this one, better than the right argument? The green argument is fine, the Grue argument is terrible. Absolutely appalling piece of argument. Given what we've just been thinking about, you might suspect it involves some kind of bias. 90 seconds with your lecture buddies, can you come up with a convincing explanation, a convincing answer to Goodman's puzzle, perhaps by appeal to the notion of bias? 90 seconds, go. So here's my thought. Because of bias, the left argument is better than the right argument because of the way the bias works. Whether apples are Grue depends on whether I or anybody else observed them. And not just that, but that in such a way as to make it more likely that my observations will support this conclusion now. So we have that, the effect of observation on what I'm observing, that making it more likely that the observations will support the conclusion. And that you can't have. You can have bias, but if you've got bias, it's got to always work against you. It's got to make it harder for you to establish the conclusion, not easier. In this case, there's a simple form of bias which affects the conclusion. Now, this is indeed exactly what Godfrey Smith himself says. It's his conclusion. I stole it from him, but I thought you might like to have it in his words. He says, putting it loosely, the apples in the sample were affected with respect to their Grue-ness by the fact that they had been observed before now. But that means we cannot extrapolate Grue-ness from the sampled apples to the unsampled ones. Because the bias is there, and because the bias is making it easier, not harder for us, to establish the conclusion. So we've worked hard on this. What have we learned from Grue?
I am pretty despicable. You don't want to cross me.
The first thing we learnt, this was from before, is that there can't be a purely formal theory of inductive reasoning. That's a very useful negative conclusion to take away from the argument. But we've also learned something by thinking about how we might solve the puzzle, the riddle, the question, what makes one argument better than the other. Given that we can only explain that by appeal to this idea about bias, any theory of inductive reasoning will have to consider sampling bias and other forms of bias besides. And that's an interesting pointer for us, who are after all interested in this question about the relation between observation and a conclusion, where the observation is evidence for the conclusion. It looks like in explaining that relation, we're going to need to appeal to the various ways in which observation can be biased.